Today we are going to look at limiting reactants. So we're going to take what we have learned with stoichiometry and apply it to limiting how much stuff we can make. So hopefully you are remembering all of stoich from last semester. We're going to put that to the test here in the next couple of days. Limiting reactants. So rarely in nature are the reactants present in exact ratio specified by the balanced equation. So if you have your balanced equation and you have your reactants, it's very unlikely you're going to have the exactly correct amounts to make the perfect reaction. Usually one or more of the reactants are in excess, while one limits how much product can be produced. So usually one of the two reactants is going to tell you, one of the multiple reactants is going to tell you how much product you can make. So the amount of product depends on that one reactant. The one that produces the least amount of product, well, that's the maximum you could possibly make. You can't make any more than that. And we'll do several examples of these to get you ready to answer these kinds of questions. So, limiting reactants. The reactant that limits the extent of the reaction and thereby determines the amount of product or products formed. A portion of all the other reactants remain after the reaction stops. And these are going to be called excess reactants. This is the reactant left over when the reaction stops. So let's say you're trying to bake, chocolate chip cookies. And you're sitting on a total of 25 chocolate chips. And, 25 pounds of sugar and amongst all the other ingredients there. Well, if it takes, 5 chocolate chips per cookie, you could make a total of 5 cookies from this, even though you could make probably 500 cookies from having 25 pounds of sugar. It doesn't matter that you had that much sugar. The maximum that you can make based on your inventory is 5 cookies. So that's kind of what this is here. This would be your example of a limiting reactant. Okay, it's your limiting reagent. The chocolate chips determine how much of a product you can make. The 25 pounds of sugar, well, that's all excess. Okay, you could probably make 500 cookies with that. Another example here, let's say you're trying to put together some tool sets. So here we got screwdrivers, pliers, and hammers. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 screwdrivers. 1, 2, 3, 4, 5 sets of pliers, and 1, 2, 3, 4 hammers. If we're going to put these in sets of 1 pair of pliers, 2 screwdrivers, and a hammer, okay, so we can make a grand total of 4 sets from this, 4 complete sets. Well, we still have stuff left over. Okay, so our limiting reactant is the thing that determined how many sets we can make. Well, what was the thing that limited here was the fact that we had 4 screwdrivers. We didn't have a 5th one. If we had a 5th one, we could complete this. So the limiting reactant in this situation is the fact that we only have 4 screwdrivers. The excess reactants in this situation are the pliers, because we have extras of those, and the, whoops, I wrote this wrong here. This should be hammers. I'm talking nonsense. And this should be pliers and screwdrivers down here. So the limiting reactant was the hammer. We had 4 hammers. The excess reactants are pliers and screwdrivers. Okay, so a sample problem here. We got S8 plus 4Cl2 yielding 4S2Cl2. The problem says if 200 grams of S8 reacts with 100.0 grams of Cl2, what mass of S2Cl2 is produced? So here's your strategy for how to solve these. Okay, we are looking at this much mass of one thing and this much mass of the other. We've got to figure out which one is going to limit how much we can make. So here's our steps to solve this. The first thing is we should always do is convert all values to moles if they're not already in moles. Multiply by the mole ratios to get us over to the product, or whatever we're looking for, that is. And then 3, see which produces the least amount of product, so whichever one makes the least amount of S2Cl2 is going to limit our reaction. That reactant is your limiting reactants. So let's try this one. So convert all values to moles if they're not already in moles. So if we're converting S8 over, Okay, that is 200.0 grams divided by the molar mass is up there in the top right, 256.48 grams per mole. Okay, and that value is 0.7798 moles of S8. And if we're doing this for Cl2, it's 100.0 grams divided by its molar mass, 70.90 grams per mole. And that is 1.410 moles of Cl2. Okay, so that's the first step there. So multiplied by the mole ratios, we had 0.7798 moles of S8. And I'm going to convert that over to what I'm trying to get it into, which is S2Cl2. So to do that, let's put our 1 mole of S8 here on the bottom, 4 moles of S2Cl2 at the top. Okay, and we'll come back to that in just a moment. Down at the bottom, we had 1.410 moles of Cl2 times that ratio. So we'll put the 4 moles of Cl2 on the bottom and the 4 moles of S2Cl2 on the top. Okay, the bottom one's easy because that's just the same value, 1.410 moles of S2Cl2. And at the top, we had 0.7798 times 4. This is 3.119 moles of S2Cl2. Okay, so now we've reached the point. We've got our mole totals. We had 3.119 moles of S2Cl2 and 1.410 moles of S2Cl2. Well, which produces the least amount of product? Okay, that was the second one. That was our Cl2 value. That one produced the least amount here. Because we can't make this. Yes, this number is bigger. We don't have enough to make it. We do not have enough Cl2 to make this value. We do have enough to make 1.410 moles though. Okay, so our limiting reactant in this problem is the chlorine gas. If you're asked how many moles of S2Cl2 are produced, well, this is your maximum right here. Okay, and if suppose you wanted to convert that back into grams, well, then you just multiply by the molar mass. Okay, and that is 135.02 grams per mole for every 1 mole. That is 190.4 grams of S2Cl2. So if you were asked about the mass of the product, okay, that's the maximum you can make. You could not make this amount. Okay, we can't make that total right there. Okay, so what happens if the problem says something like this? How much S8 is left over as excess in grams after the reaction has occurred? Okay, so we know that this is supposing immediately just by reading this, you know that the chlorine, okay, is limiting. It's the limiting reactant. Just by reading that, it says that the S8 is in excess. That means you've got more of it. We want to figure out how much is left over. Okay, so going back to that chocolate chips and sugar example, you got a ton of sugar left over. Well, here, let's figure out how much of the sulfur is left over after the reaction. Well, we've already done a lot of this. We know the moles of the limiting reactant. Okay, that was of the chlorine. All right, that was 1.410 moles of Cl2. We've already done that work. Okay, limiting reactant here was the chlorine. We've already figured that out. We're going to multiply by the ratio to get us over to S8. Okay, and we're going to subtract that value from the moles of S8 present before the reaction occurred. Because however much is left over is what you start with minus what you use tells you how much you have left. So, moles of limiting reactant, that was 1.410 moles of Cl2. Multiplying by the ratio, 1.410 moles of Cl2 times, okay, this is going to be our numbers from right here. So if I'm using chlorine, it's got to be on the bottom, 4 moles of Cl2 and 1 mole of S8 on the top. So we got 1.41 divided by 4. Okay, with 4 sig figs, this is 0.3525 moles of S8. Okay. Well, if we want to figure out what the mass of that is, okay, that's what step 3 is going to be. We've got to figure out how much is left over. Okay, so we started with 200.0 grams of S8. That's what the original problem had. How much got used, so this was total. This is how much we had total. How much we got used, we just calculated. That was what we found on the previous one there. Okay, the 0.3525. So to figure out that one's mass out in grams, we're going to take 0.3525 moles of S8, okay, because we're not in grams, and we are going to multiply times its molar mass, which was 256.48 grams for every 1 mole. That's 8. Okay, so that will give us 90.41 grams of S8. This is how much, let me put these in parentheses here, this is how much got used. That's how much was used. So if this is how much we started with, this is how much we used. To figure out how much we have left over, subtract this value right here from the moles of the present before the reaction started. Well, we're already in grams, so we've kind of cheated and gone ahead and just put it back into grams. Okay, so that's just going to be 200.0 grams of S8 minus 90.41 grams of S8. Okay, and that is 109.59 grams of S8. Okay, and if we wanted to convert that into moles, you could divide it by its molar mass. Okay, and in moles that is 0.4273 moles of S8, just depending on what the problem would ask you to solve for. Here it didn't specify, so I probably wouldn't be specific, but you could give either answer there. Okay, so we will stop there for now. We will continue on with percent yield later on.